Okay, welcome back, and then we are going to start a new topic on MIMO. Okay, and that's important in a certain context, and it will become clear once we finish the discussion. What is just a quick summary? Okay, so whatever like the precoder design we have discussed. Okay, we have assumed that a TDD reciprocity. Okay, and I want to bring out this aspect wherein like if this reciprocity is not there. Okay, if it is a FDD system, correct, how does this precoder design happen? Okay, and it is like important to understand this because when we designed this precoder for TDD, even for TDD system, we assume this the TDD reciprocity, which in general, as I said, requires certain kind of calibration. Okay, TDD calibration. If that is not done, uplink and downlink channels are not same. Okay. So, this uplink and downlink channels need not be same for two reasons. One is if it is a FDD system, and second one is if the TDD system is not calibrated. What does this calibration means? That the uplink chain, okay, you are estimating the uplink channel. So, what is involved there? UE transmitter and base station receiver, correct? That has certain gains, okay. So, UE transmitter will have a certain gain, and then base station receiver will have certain gain. Okay. Now, what are you looking at? You are looking at the downlink channel. What is involved there? Base station transmitter and UE receiver. Those two components are different from this. So, this makes this uplink and downlink channel uncalibrated. Okay. So, that needs to be corrected. That is a non-trivial task. Okay. So, now this one. So, what happens? So, we assume if the channels are not same, uplink and downlink channels are not same, how will the base station design the precoder? Okay. That is the objective of this class and the subsequent class. Okay. When I will teach you what is called as the codebook based precoding or codebook based beamforming. Okay. So, for FDD system, as I said, downlink channel information is difficult to acquire at G node B, as I just said. Gave you an example. Okay. So, what happens? So, now if base station does not have the channel information, who actually has the downlink channel information? If the, let us say, base station transmits the CSIRS, okay, right. So, UE will estimate the channel, UE has that information, UE needs to feed back this information back to the base station. So, we are discussing how the UE feeds back this information back to the transmitter. Okay, right. So, we are going to understand this, and that will complete our discussion on MIMO. Okay, how it is done in the standard. Okay. So, 5-year defines something called codebooks. We will see what these codebooks are. Okay. Then once I show you, it will become immediately clear. Okay. So, 5-year defines these codebooks to enable the UE to feed back the channel information. UE needs to feed back the channel information. How does it feed? It uses, there is some, it is called scaffolding, which is defined for the UE to send this information back. Okay. So, the system helps the UE in feeding back the information to the base station. Okay. So, this kind of codebook based precoding or codebook based beamforming can be used for TDD systems also. As I said, downlink channel, uplink channels are not exactly reciprocal. Okay. So, this idea of codebook based beamforming is applicable for both TDD and FDD. Okay. Right. So, learn how these codebooks are used to feed back the channel information. So, slides whatever I teach you, they are self sufficient, you do not have to refer to any other thing. Okay. So, that brings us to we will consider a simple example, and this example is applicable for other bigger systems also. I am considering only 2 antenna system, right. Okay. So, what are we saying here? So, we are considering a downlink, okay, where 2 antenna G node B transmits to a single antenna user, a simple system to understand this idea of codebook. Okay, right. So, what is G node E wants to like perform this beamforming, and we have understood what is the like best beamforming or precoding base station can do. We saw that, right, H1 star H2 star transferred by norm of H. This is what we learned in the beginning of MIMO transmission, correct. Okay. Base station wants to do this, but it does not have this information. How will it do? Because in order to precode this to use h1 star over norm of h over here, h2 star over norm of h over here, it has to do this, it needs to have the channel information, doesn't have that, okay, correct, okay. And that's the case we are considering, how this problem is solved in the standard, okay. So now what will it do? How many antennas are there? 2 antennas, right, okay. And what does UE need to do? UE needs to estimate this unprecoded channel because there is no precoder, correct, okay. So this H1 and H2, how many ports CSIRS base station will have to send? 2 ports CSIRS, correct, okay. So if the base station sends this 2 port CSIRS, user can estimate H1 and H2, these 2 channels. We understand it very well, okay. We have done this exercise so many times. And what will happen? So UE has this information, H1 and H2, correct. So UE has to feed back this information back to the transmitter. Now you look at it, what is H1, what are H1 and H2? H1 and H2 are complex numbers, right, okay. Complex numbers whose phase can vary between 0 to 2 pi, and amplitude can now also vary quite a lot, correct, okay, right. So what are we saying here? That either if UE has to feed back this information, UE needs to, how will it send? It's all digital transmission, right. What will UE send? UE will send it over the control channel. What are you sending in control channel? Okay, certain number of bits you can send, okay. And how will you send this information? You quantize this just for phase, okay. You quantize that information into 0 to 2 pi, okay. Let's say you quantize into like with a resolution of 1 bit, okay. You will have 360 different angles, correct. And how many bits will you need to basically send that information? 2 raised to power 9, 5 and 12, right, okay. More than 256, okay. 9 bits you need. Similarly for the amplitude, I am talking only about the phase, 9 bits for phase. What is the phase of this H1? 9 bits for this, 9 bits for this, only about the phase. There is the amplitude also, right, okay, fine. So you see the overhead, the control overhead which needs to go from the user to the base station to feed back each of this complex channel, and I am talking about only 2, there can be 64. There could be 32, right? 32 port CSIRS has been defined in the standard, correct, okay. So for the UE to feed back this channel information to the base station, it's a humongous overhead, correct, okay. Now with this kind of overhead, like for each of this antenna, it is not practical to feed back this information, okay. And so what is commonly done in this case is as follows. That's what we are going to discuss in order to avoid this H1 and this high overhead, okay. So that's where this notion of code books come into picture, and that's what I'm going to show you, okay. What is this code word, okay. So this crude way of sending this information, quantizing phase and magnitude, is going to cost a lot of bits on the control channel. You understand? I gave you the simple example, okay, and then this it will require a large number of bits, okay. For such a system, rank is 1 and number of layer is 1, right, okay. Then if basically what are we saying? If UE has 2 antennas, right, it has to basically 2 cross 2, it has to, the number of channel is increasing. Precoded, it's not precoded channel, it's unprecoded channel, right. Channels are increasing correspondingly, right. So forget MIMO, you cannot implement it because it is a lot of overhead, okay. So and the solution to this is designing the system in a particular way, okay, and that's what we are discussing in this class, okay. What is this? Code book, okay, and I'll introduce you to this notion of code book, what does that mean, okay, and we'll discuss it for a simple case in the beginning, okay, and the idea remains same for large number of antennas also, okay, right. So let's do it for 2 and it will become clear how it is done for 64 antennas also. But what are we assuming? If the UE has only 1 antenna, you can transmit, what will be the maximum rank? Rank will only be 1, right? Okay, fine. So 5G defines these code books which UE uses to indicate channel information to the G node B. Okay, and what are these code books? So what will the rank of the channel? Rank of the channel can only be 1. That is understandable. Okay, so rank 1 code book for 2 antennas. Okay, there is an example code book. Okay, so if time permits, we will later discuss this code book for higher number of G and B antennas used in the 5G. I don't think we will have time, but I will show you this and how this is used. Okay, so what is this code book? Okay, this is the code book 1, 2, 3, 4. Okay, what is the book? It has different entries. Okay, so this all 4 of them form a code book for a 2 antenna system. Okay, right? And how many entries it has? It has only 4 entries, right? And they typically what are they telling you? Okay, they are telling you that the channel looks like this. Okay, right? And let's try to understand what is there in each of this. This is a 2. See what is the dimension of the channel? Dimension of the channel is 2 cross 1, right? Okay, NR cross NT. So it's a 2 cross 1 vector. The channel dimension is this only, right? 2 cross 1, 2 cross 1, 2 cross 1. Now what is this code book telling you at first place? That the whole of this channel, whether it's amplitude or phase, okay, it has only been quantized into 4 different values. Okay, digest this idea. What am I saying? That this is the code book which UE will use to indicate what channel it is observing. The statement I am making is that UE will use one of these entries to indicate back to the base station what is its channel. Okay, right? How does it do? I will tell you. Okay, which code book entry will use to indicate the channel. Now there are 4 different entries, right? UE has to pick up one of these entries to indicate what its channels look like, right? Okay, fine. So now what is the overhead of this kind of code book if the UE has to indicate one of the entries to the base station? Okay, only 2 bits, right? Because UE will require either it will have to tell whether its channel is this or this or this or this. Right? UE is not given any other option of indicating to the base station how its channel looks like. It has to indicate from one of these entries. Okay, right? If that is the case, what is the overhead? Only 2 bits, right? For this kind of code book. Fine. So what we are claiming here is by defining a code book like this to indicate the channel, right, to the base station, we have reduced the overhead to only 2 bits, right? And if you look at this carefully across these 4 entries, what is changing? Look at this. If you look at the amplitude of all of these channels, see what is this? If you look at the first entry, what is this? This is H1 and this is H2. H1 and H2. We are indicating the channel using this, right? 2 cross 1 channel using this codebook entry. If this is the codebook entry, what are we indicating? What is the amplitude of the first entry? 1 by root 2. What is the amplitude of the second entry? 1 by root 2. Right? Okay. So amplitude is same. Right? Okay. Look at here also. What is the amplitude of this entry? 1 by root 2 and minus 1 by root 2 and 1 by root 2. What is minus is the phase. Right? 1 by root 2, here is amplitude of channel is 1 by root 2, amplitude of the channel is 1 by root 2. Look at here, again the amplitude is same. What is changing is only the phase across these channel entries in these 4 codebook entries. Right? Here the phase between H1 and H2 is 0. Here the phase between H1 and H2 is 180. Here the phase between H1 and H2 is 90. Here the phase between H1 and H2 is 270, right? So what are we saying here? Okay, that the UE will feed back only the phase information back to the transmitter. It will not feed back the amplitude information to the transmitter. Okay, and phase is also quantized only into 4 different values. Right? Here the phase is 0. Here the phase between 2 channel elements is 90 or 180. Here it is 90. Here it is 270. Because with 2 bits, what kind of quantization you can do? You can quantize 2 pi into only 4 different angles. That's what is happening. right? Okay. So what are we saying here? That instead of quantizing the phase into 1 degree each, you are quantizing the phase only into 90 degrees, and that's the information you are sending. UE will send it back. Okay. So, and of course, like if you are sending fewer bits, you are sending lesser information back to the base station. That's what it means, right? Okay. So now, so that's, you understand, right? So what have we achieved with this code book? We have reduced the feedback to only 2 bits, and what are we feeding back? We are feeding back only the phase information between these 2 channels. If I send this code book entry, if the UE sends this, indicates that this is a channel, what is it sending? H1 and H2 are essentially the same. What is it sending over here? H1 and H2, the phase difference between H1 and H2 is 180 degree. Phase difference between H1 and H2 is 90 degree. This is 270 degree. Not indicating how much amplitude of each of this channel is. It's not, because you are not allocating the bits to send, you are not allocating bits to send the amplitude information, because all of them have the same amplitude, right? Okay, but the amplitude can be different, right? But if you have to send that amplitude information, you need extra bits to quantize the amplitude and then send it, which essentially means the entries will increase, right? Okay, correct. Just for example, if I want to, for this phase itself, I have to quantize, okay, 0.1, 0.5, right, 0.5 and 1, the number of entries are doubled, right? Instead of 4, it will become 8 entries, the number of bits is going to increase, correct? Okay. What are you sending? Only 2 bits, and that too they are assigned only for the phase, right? Okay. So what are this? This codebook contains 4 precoders, okay, VI1, VI2, and each precoder has a unit power. Look at this, okay. But more crucially, each channel has the same amplitude, okay, right. So this is how it is defined. Now the question what we are asking here is, okay, that how will UE indicate to the base station that this is how its channel is, right? Okay, it has to indicate using one of these entries, correct? Okay, fine. Now what? How does it do? How does it do that? How does it perform that exercise? What does it do? UE assumes that G node B is using one of these precoder entries. This is the precoder. Okay, right. So let's say, what am I saying here? If the channel is this, let's say, okay, what precoder base station will use? Hermitian of this, right? H Hermitian. Correct? Okay, right. So what is it? What it will use this fact, it will assume certain things. Okay, what is, so base station has UE has this, UE knows this channel exactly, H1 and H2, it has, okay, but it needs to feed back this information, and it has gotten only 2 bits to do that. Please understand this, UE has estimated this channel completely. H1 and H2 it could estimate using CSIRS, right? But to feed back this information, it is given only these many bits, or these are the codebook entries, okay, right? So what happens after this? So what does UE assume? UE assumes that G node B is using one of these precoder entries, okay, right? Let's see that. So what will happen if G node B, if this is the precoder, if Vi is the precoder, okay, what will it transmit from first antenna? Just, it is assuming that, UE is assuming that, okay. It will transmit Vi1 X, because rank is 1, what will be transmitted from here? Only one symbol, X, and that will be precoded using this precoder, one of these precoders, okay. What am I telling you here? So this is the precoded signal which is being transmitted. What will be transmitted from first antenna? Vi1X from first antenna and Vi2X from second antenna, okay. So what signal it's going to receive? This is a channel from first antenna, this is a channel from second antenna. this signal gets multiplied by H1, this signal gets multiplied by H2 plus N. This is a system model for this 2 cross 1 system, right? Okay. What happens? I can write it like this: H, channel H, the precoder Vi into X plus N. I am defining the channel as H1, H2 like this. What is precoder? Precoder is a column vector. I am defining this as a row vector. Okay. So, inner multiplication, and this is how you can write it, right? Okay. Precoder, UE knows this H, fine. UE estimated this H using CSIRS. UE knows this precoders, and how many such precoders are there? How many such codebook entries are there? 4 codebook entries. What is it going? What does this UE want? The UE wants to select a particular precoder which will feed back this channel information to the base station, right? And in this case, what is the objective? UE will pick up a precoder which indirectly indicates what the channel is, right? What is this precoder? One of those codebook entries, right? Why does UE need to send back this information H back to the base station? So that it can use, base station can use one of these precoders, right? Okay, so what is UE doing in this case? Instead of indicating the channel H, it is indicating to the base station, please use this particular precoder, okay? And how will it choose this particular precoder out of these 4 different entries? What will it do? What is the idea? What is the objective of this? Of the UE when it has this received signal? It has to maximize this SNR, right? What are you doing here? You are transmitting only a single symbol. The single symbol gets precoded, it undergoes through this channel, the signal is received at the receiver at the single antenna, right? Okay. So now if this is the received signal, what should UE do? UE should pick up a precoder which maximizes the overall signal strength, correct? Okay. And if it picks up a precoder which maximizes signal strength, what does that mean? Right, its job is done, because what is that actually this precoder indicating? Somehow it is indicating the channel which the UE is observing, because which precoder is going to maximize this? Which matches with the channel, right? What did we understand for the maximum ratio transmission? That H1, H2, the precoder you should use is, if this is a channel, you should use H1 star over here and you should use H2 star over here, divided by the normalization, norm of H. And what did that precoder do? It maximized the SNR, right? So what am I going to do? How is this user going to pick up this precoder out of these 4 entries? It knows the channel, it knows these precoder entries. What will it do? It will do the inner product, find out whichever entry is giving the maximum value, because what is this? HVI is a scalar number. Inner product of 2 vectors, you are going to get a scalar value which will indicate the SNR or the signal strength, right? What is the signal strength here? HVI, the power of P, the power of X, that is P. It assumes that power of P is transmitted. Okay. What is going to decide the signal strength? H into V of I, right? So what is the SNR? HVI P by N naught, right? Okay, correct. So UE will choose this precoder which will maximize the SNR, correct? And what will it? How does it do? It do this product for all 4 different values, right? And whichever value of Vi maximizes the SNR will feed back that information back to the user, to the base station, right? Okay, so that's what I am saying. UE will choose this Vi which maximizes the SNR, okay, feeds back this index of above precoder matrix or vector with maximum SNR it is observing, okay. Now what is happening here? This index is called the precoder matrix indication. Okay, I will use this term. I did not explain in detail. What is this? PMI. What is it telling you? Which one of the precoder matrix base station should use? Okay, this is PMI, and So what is, okay, so this has happened, okay. Now let's continue this, okay. So if base station has the complete channel information, as I, okay, just as what would it do? As I said, it will transmit H1 star by norm of H from here, it will transmit H2 star by norm of H from here, correct, okay. And this is the precoder. It will use if it has the complete channel information, which it doesn't have, right, okay. So what is it trying to do here? It is trying to do this MRT with the limited channel information, correct, and how many bits it requires? It requires only 2 bits of feedback, okay. Now what is happening? Let's try to understand over here, okay. Then we go back over here. What is the intuitive understanding? What is the intuitive way to understand this? Which VI will maximize this H if the base station has complete channel information? This VI1 should, what it should be? It should be H1 star by norm of H. What it should be? VI2, it should be norm of H2, right, okay. It should be H2 star by norm H, right, okay, fine. Now that cannot be done because base station does not have the information, okay, though it would like to do that. So what is UA doing? By looking at each one of this precoder, it is trying to find out H1 star here and H2 star here, right, okay, because which one will maximize, which VI will maximize this SNR, okay, when these two signals add up in phase, right, okay. You have to see what is happening here. You look at the 4 different values of those channels, okay. What are we saying here? That if you have the complete channel information, you would like to design VI1 as H1 star and VI2 as H2 star divided by norm of H. But since that cannot be done, I am finding out approximate H1 star and approximate H2 star, which is given by these VIs. Is this making clear? That because what is contained in VIs? This phase information, right, okay. So if H1 is basically something like this, H1 is 0.3 and 0.3, right, which VI UE will pick? Which VI will maximize the SNR out of these 4? If the channel is 0.3 and 0.3. Just one example, right, this or this one. Because what will happen? This will help these signals from these two antennas add up in phase, right, fine, okay. Now if the angle is, let's say, if the channel is such that 0.3, okay, and minus 0.3, correct, okay, and that's a channel 0.3 and minus 0.3, okay, which codebook entry will be picked? Second one, because what is happening? These two channels will get added in phase. Go back, what is happening? It will be H1 VI1 star VI1 plus H2 VI2, right. If H1 is what? 0.3 and this is minus 0.3, which precoder entry will get picked? This one, right. So what is happening here is, when you do this operation, precoder entry which is getting picked is basically helping the channel getting added in phase, okay. And you could say that, okay, but if the angle could be different, slightly different, right, and the need not be between exactly the angle need not be exactly 90 degrees, if it is slightly lesser than that, right, okay, 85 degrees, right, 70 degrees, 50 degrees, okay, right. People have shown that quantizing angle like this gives you the best possible performance. There will be some degradation because you are not exactly quantizing to the angle which these channels are observing. What is happening? We are quantizing the angle only between 4 different values, right? But the angle could be different, right? What are we saying here? If you quantize the angle into 4 different angles, you get close to the best performance. Okay, this is not the best performance, but you will get close to the best performance if you quantize only 4 different phases. Of course, if you quantize into 360 different phases, it will still give you a better performance, but the trade-off between the number of bits you have sent and the performance gain you get is not good, okay, right. So, with what people have done is, okay, the kind of simulations people do, that they see that, okay, you design codebook with 4 different angles, you design codebook with 64 different angles, what is the gain, okay, how much performance degrades in this 2-bit quantization when compared with 6-bit quantization, okay. People realize that this gives you the close to best performance. After that you get diminishing returns by increasing the number of quantization levels, okay. So, for this kind of system, this kind of codebook is enough, okay. So, that is how it is implemented for a 2 antenna system, okay. Similar ideas are there for, let us say, the 64 antenna system, okay. You will have a bigger size codebook, right. Each of this entry should have 64 cross 1 entry, right. The size of each of this channel should be 64 cross 1, okay, and there should be larger number of codebook entries, okay, right, because you have a larger number of antennas, correct. So, that is a separate exercise in itself, it is given in the standard, how many bits are defined for a 64 antenna codebook, how many codebook entries are there. But if we understand this, that for 2 antenna codebook, there are only 4 entries, and UE will have to feed back only 2 bit of information to indicate the channel back to the base station. And how is it indicating this channel back to the base station? By directly indicating the precoder which it should use, right, okay. This is the precoder entry. It does not care, right, what does base station need to, why will base station care about the actual channel? It only needs this precoder over here, which U is feeding back to the base station, and which precoder U is feeding back? It is feeding back that precoder which maximizes the SNR, right, okay. And this precoder is picked up from a codebook entry, from a codebook which has only 4 entries in it, and to feed back this precoder only 2 bits are required, okay. And having this kind of codebook gives you close to the best performance. Of course, it is not the best, right, because you are quantizing, you are not even quantizing the amplitude, you are quantizing only the phase, okay. And you could ask this question, why only phase? Because if phase information is not there, the signals will cancel each other, right, okay. If the channel is 0.3, minus 0.3, and if the codebook entry is only 1, this channel will cancel each other. The signal you will receive at the UE will be 0. We have seen that kind of loss, okay. So, I will stop here, we will continue discussing this. Thank you.